Hello, this is Kaylin. This is a tactile graphing tools video. I'm going to cover a set of options that blind people can use to graph independently and a set of options that educators can collaborate with their blind students with a visual medium that the blind students can feel tactily. So the first option is the blackboard. This is essentially a rubber mat that when a printer paper, just a piece of regular printer paper is put on top and you use a regular pen, you can create tactile graphics. This is a great option for both teachers making graphics on the fly and blind people making graphics in real time in class. So this is a piece of just plain white printer paper. It's resting on top of this blackboard, which is about the same size as the printer paper. It's a very thin rubber mat. And then I'm using just a regular black pen. I'm going to draw the graph of y equals x. First I'm drawing my axes. You can push kind of hard because it's the resistance and the pressure of the pen onto this blackboard that makes it puff up on your side. I'm drawing my next axes, and then I'm drawing the diagonal line between these axes, which is the graph y equals x. Now, there are some amazing assets in this thing. For one thing, it is super easy to find the materials. Any black pen, any pen, and any piece of printer paper can be used with it. You also have to consider that it's facing the same direction that you intended to draw it, while several other mediums require you to flip it over to then feel the graphic, meaning that you have to do everything in reverse, which creates extra mental load on the blind person to graph accurately. This is also great for teachers because they can see your work with real ink, which makes it easier to grade and also for them to conceptualize their own thoughts when teaching blind students. So this is a great option. It's also very, very thin, fits in a backpack. Next, I'm going to move on to a technology called the Draftsman. This is a very similar construction, except for it's even more sensitive and provides even better tactile feedback. So the Draftsman is a very similar design. It has a foam base with plastic around it. This plastic is basically used to hold this thing in place. So each sheet, this is a packet full of Draftsman sheets. It's like a slinky piece of plastic. It's pretty thin. It kind of has like this texture. If you listen, it's slightly rough. It's just my nails rubbing against it. With this, you hook this sheet into place with these little crampers on each side. There's one on the top and one on the bottom, and this allows you to pin the paper or the plastic sheet in place. Then it provides you with a plastic stylus. This has no real ink. It is simply a plastic pen. There are two different point options. One is a larger ball point, while one is a more fine pencil type point. It also comes with a ruler, which allows you to measure in tactile, like it's not actually in Braille, but it does have tactile markings for you to measure. It also allows you to create straight lines. It can be attached at pretty much any point on the top, bottom, or right side of this board, basically ensuring that you can create straight lines and that you can measure on this thing. There's also a built-in pencil holder for your stylus on the left top side of this thing. Though it will sit nicely when it's laying flat, it doesn't have any grip, so it will not hold it if you were to lift the pad up. I'm going to quickly demonstrate this with that same graph of y equals x. This also has the added benefit of the fact that you can feel it when you're drawing in the same orientation, meaning that you don't have to flip the paper over in order to feel your graph. But it has even greater sensitivity. So with this previous one, this is the previous graph, it is quite thin. It's also quite brittle, as in you can actually break apart the paper if you push hard enough with your pen to cut out shapes. This could be quite cool in some scenarios, but it's not super detailed, and you have to be quite sensitive with your fingers in order to feel the graph, especially if it's not something that you yourself graphed. That can be somewhat hard to follow. Here it's super easy to feel the lines, almost as nice as a properly printed tactile graphic. And you can add really nice details like markings along the X and Y axis. You could even do Braille labels, but this does have the added issue as they do not pop back up in your direction, meaning that your Braille will be pushed down and will likely not be feelable. That said, if you draw them big enough, you can often feel roughly drawn print letters, which is also good for when you're handing in an assignment to a teacher. This is also quite easily visible for a teacher if they were to hold it up to the light, as the places where you marked are quite noticeably more white than the outline paper, which is relatively clear. So this is an amazing option and is far more pleasant to feel and interact with than the blackboard, but it is a bigger profile device. It does take specialized paper sheets, and it is overall more expensive than the very, very cheap blackboard. So next I'm going to talk about another option. This option is Wikisticks. These are a child's craft material and are often used in elementary school, but they can be used to graph somewhat primitive shapes. They're also very, very good when working in tandem with 3D models or a built-in, already printed tactile axis. That said, these are definitely not my favorite method, as they are quite easy to move around, meaning it's hard to feel them without moving around the shapes, and also they have no form to them, so you can't add any sort of tactile labels or any sort of markings along the x and y axes. So here is again the x equals y graph, but it is formed in Wikisticks, just free form. They are somewhat sticking to the desk in this moment, but usually they will not stick to all surfaces, and they will often slide around as you're trying to feel them, which is quite frustrating. But these are a great tool if you are doing a test or trying to teach blind students on the fly. Okay, now I'm going to move on to a section that is mostly for geometry classes, or classes that require physical figures and models. These are some more tools that are especially useful for geometry purposes. This clipboard can be used in the same way as the previous two devices, the Blackboard and the Draftsman, but it does come with a specialized geometry set that is available online. I'm going to demonstrate its use with both regular printer paper and with specialized Braille paper. For those who are not familiar, Braille paper is a sort of cardstock. It is slightly thicker than regular paper, but it's not quite as thick as traditional cardstock. And here is the printer paper. So these are the two paper options. I typically like the Braille paper better, whereas the printer paper is definitely better for when you're using the Blackboard. First, I will demonstrate the printer paper. You slide it into this clipboard type contraption, and then you shut this lever. It kind of punches holes in the paper, and then there is a locking mechanism to hold everything in place. Now, this set comes with a few implements that I call pizza wheels, but they are actually called spur wheels. They're, I guess you can kind of imagine that they're like the spur on the bottom of like a cowboy boot, but to me they look more like pizza wheels, and you kind of hold them like a pizza wheel. So that is what I call them. It comes in three different variants of the distance between the prongs, which allows you to create different lines on the same page, potentially graphing the axes in a different line than a graph, or graphing multiple functions at the same time. Essentially very, very useful. So basically you kind of hold them like a traditional pencil, but you are letting the wheel part indent the paper. They are a lot less easy to control than either the stylus or the pencil. The pen that was used with the Draftsman and the Blackboard, but they do create quite precise lines, and they can be used with a ruler to make even more precise lines. This again is the graph y equals x, but as you see when I flip it over, it is actually the inverse. This is one of those technologies that requires you to flip over the paper in order to feel the tactile markings, meaning that you would have to draw this in reverse if you wanted it to be a traditional y equals x graph. So while this is quite useful, it is less efficient for the purpose of freeform graphing than the previous two options. That said, its strength lies more in what it can do for geometry constructions and for very, very precise measurements. So if you see here, I am locking in the Braille paper this time. You can use a variety of different materials with this device. Here for one is a Braille ruler. There are two Braille rulers in my collection. They come from different sets. This Braille ruler came with a larger set of different construction materials, while this ruler I think came separately. I prefer this one not only because the indents are better delineated with braille labels, but also because of this amazing tool that allows you to mark a measurement on the ruler. This is especially useful because as a blind person, I would have to feel and potentially count every single tick to get back to where I needed to measure, which is challenging when you're juggling both a pizza wheel and a ruler in different hands, and trying to hold the clipboard still. It can be quite tricky. Also, this ruler has physical indentations on the sides, which often trips up the pizza wheels and kind of makes them get stuck to it, which can be quite frustrating when trying to draw a material. Again, I cannot feel this on this side, but I can feel a slight indentation on the other side, which means that it will show up when I flip over this paper. Now, this ruler is also super nice because it does not have super physical indentations on the other side, meaning that it allows you to not catch the pizza wheel as you're using it. These sets also come with a variety of other triangle figures in different sizes and proportions, which can make it easier to, say, trace a triangle to use, like with the previous two tools I mentioned, the Draftsman and the Blackboard, or they can be used for precise right angle measurements when you're doing constructions. This triangle specifically, I've not specifically used these very often in geometry because they usually require you to do your right angles with a protractor rather than relying on a physical template like this. I will demonstrate a variety of different protractors I have in my possession. This is the traditional looking protractor that looks very, very similar to that the fully sighted students use. The challenge here is that there is no real clear center point that you can actually line up with a ruler. If you were trying to use a ruler concurrently with this device, the ruler has to sit on top, making it too high for these pizza wheels to work with it. You also cannot draw a line longer than the edge of this figure, and it is very, very hard to line up and draw a straight line. Essentially, this, while it may be a more normal looking tool, is very inconvenient to use and ultimately less practical than many other protractor options. So here are two other protractor options. This one also came with one of those larger geometry sets. It does have some benefit in the sense that you can line it up with a specific measurement and draw along here or here with your pizza wheels or spur wheels. The hard thing here is that this is slightly elevated, making it kind of inconvenient to hold this pizza wheel along the slide as it's slightly higher than this distance. So it's not super useful with the pizza wheels. This would be easier to use with the stylus or the pen used for the previous two options, but it is still not the best option. My preferred option is this additional protractor. Not only does it have modified braille type labels, but it also has a more streamlined design that allows me to keep it closer to the ground and use my pizza wheels properly. It also is easier to line up with a specific measurement due to this very, very fine point. So this is definitely my recommendation for the best protractor for geometry. Now I'm going to introduce you to a few different compass options. This compass is very similar to the pizza wheel design in the sense that it has one of these little mini pizza wheels on one side and a hard point on the other. This is pretty similar to the the compasses that the fully sighted students use. They have a hard point and they usually have an attachment for a pencil on the other side, so when it spins around, the pencil draws. This is not so different. You can indent it into the foam, and you have to maintain a constant pressure, which is kind of tricky on a moving clipboard, but you can draw a full circle. I will demonstrate this when I flip it over. The challenge here is that this will not exceed a pretty small measurement, meaning that for any figures that you need to draw that are bigger than this span here, this protractor is useless for. Sorry, this compass, oh my gosh, I keep messing up my words there. This compass is less useful for. There is an alternative compass that I quite like because it is both easier to use, it is more steady, and it is also a far greater range of distances that you can have in it. It also comes with 2 different pizza wheel attachments, so you can draw 2 different circles on the same page with different lines. This is basically the equivalent of coloring them differently for a fully sighted user. For the sake of example, I'm going to take one of these off this pizza wheel. One of these pizza wheels off this compass. You just unscrew this top part, and then it slides right off. This also has the same little point that you saw on the previous compass. Again, you push hard, and then you can have it come around like a traditional circle here. I only did a half circle due to the space on the page, but this can go all the way up to this full distance, which is about a half a foot, making this very, very versatile for a variety of different assignments. I'm going to quickly flip this over to demonstrate the beautiful tactile feel that you have here. One thing I do also love about this compass is that each of these has 2 different prongs. That this one has 2 prongs and this one has 1 prong, meaning that this kind of feels like a double line while this is only a single line. This makes it far more easy to distinguish them, and this makes it unlike anything that these other pizza wheels have produced, which makes it unique and easy to distinguish. So again, this is a super awesome tool for when you're doing geometry constructions or more strict measurement shapes, while the others are definitely better for free-form graphing and when you just want a paper to show you back exactly what you drew rather than having to flip it over and see the reverse image on the other side, which again adds significant mental load to a blind person who is trying to learn math just like anybody else. So this is a great tool. This is also definitely very much harder for a teacher to become accustomed with and to use on their own, and is usually probably better used by the student, whereas some of the other previous options would be better for a teaching aid. Lastly, I would like to introduce you to the final option. This is called puffy paint. There are a variety of different options where this is concerned, but essentially it allows you to create your own tactile graphics or annotations on tactile graphics with puffy paint, and then when it puffs up, you have tactile imagery. This is often used for the creators of tactile graphics who perhaps had like a mess up or they wanted to add a marking, and they can go in later and use this tool. This is definitely not super useful for blind people themselves because we can't exactly see where we're putting the puffy paint and we can't feel it until it's dry, so it's definitely a long-term fix and probably better used for a teacher or vision impairment creator of tactile graphics or materials. But a great option. Anyway, thank you so much for watching, and I hope that all of these tools will be very helpful to you in your math classes and beyond.